So it's my pleasure to introduce you Sy Bohy from SIM. Probably you already know him. He has a background in multiple engineers field and startups. Now he's a CEO of SIM, and with SIM he has the goal to build an API for the things around us. So the floor is all yours, Sy. You can start.
Yeah, like Cristiano mentioned, I'm Sy. I'm the CEO at SIM. I'm pretty happy to be here. We've been sort of like kind of reading the web of things, and also some of the work Mozilla has done on the topic of sort of standardization around IoT for a while. We drew a lot of inspiration from it. So kind of the topic of the talk today is designing an API for the physical world, and you'll sort of see what that means over time and where we draw heavily from kind of like the work that you guys have done, and then areas where we sort of really take a user story driven approach and we diverge a bit, because ultimately as a business, I guess we're trying to solve problems that customers are willing to pay for, like and provide solutions to their problem. So just real quick, some like background on myself. I grew up in the French Alps. I attended Stanford for college. I was sort of cursed with the everything is kind of interesting, and so I'm just going to go study a bunch of different stuff. So I did some material science, which is actually where I got my degree. Did a ton of electrical engineering. This is kind of an old photo I found of myself kind of building my first op amp, and obviously a lot of computer science. My first job actually started as an internship, and it was at Nest, the thermostat company. And it was a really interesting point in time, specifically for IoT, because you basically had sort of the people that had brought you the iPod and the iPhone, and who had worked to sort of kind of shrink computers such that they could be put in your pocket. And they were sort of standing at sort of the tail end of those efforts, and kind of realizing like, okay, well, computing components are super small, and they're also super cheap because we've shipped over a billion mobile devices, and so now there's very low cost RAM and CPUs and so forth. And their realization is that computing was going to get embedded into absolutely every object around us. And they kind of were looking for an entry point, and that entry point to build sort of a consumer-facing company was to build a thermostat for initially the American home, and eventually sort of like every home globally. And so, like I said, I joined as an intern. I think my intent at the time, at least, I would have desired to kind of go back for a PhD, probably to Stanford. And the founder of Nest sort of kind of grabbed me, and toward the end of the summer of the internship was like, you're not going back to school. You're going to get a PhD in building things, and so I stayed at Nest. We sort of, we get acquired by Google a few years later. And it was really interesting. And I think a lot of the lessons that come out of sort of seeing the IoT space, the consumer, but also the enterprise space of IoT sort of evolved over the last 10 years, eventually lead us to kind of starting SIM. And so I'll talk a little bit sort of in the next slides about that context. So, we started SIM in 2020. We really spent a lot of time kind of understanding like the customer needs, what exactly was going on in the space. We are now based in San Francisco, in the Mission District, but we have people kind of all over the world, which helps with that sort of 24/7 support, service that we want to provide. So the context around SIM real quick before I go like into like some of the more technical parts of this talk. I think sort of 10 years after Nest was sort of started, I still like to think that IoT is just kind of getting started. Right now, I think the net deployment rate is on the order of like 2 billion devices. How many IoT in the world, devices are in the world today is not entirely clear. You kind of keep hearing different numbers depending on who you talk to. What's very, very clear is that it's still growing very, very, very rapidly. And, at the start of SIM, what we saw as a problem is we had, being in Silicon Valley, we had a lot of friends kind of doing startups or, writing applications for, larger tech companies. And very often we heard, oh, I'm trying to integrate, I'm trying to control this IoT device from my application, and it's very difficult because, I contacted the manufacturer and I asked for, do they have a third-party API? And the answer was, well, we have a SOAP API that we wrote 20 years ago, and pay us $250,000 to give you access to the documentation. And and I'm exaggerating a little bit, but like I think very often it's actually not that far from the truth. You get these big PDF that are like 900 pages long, and it's impossible to search, and you're just like I'm like, dude, I'm just trying to unlock a door. Like it shouldn't be this hard. And so kind of the realization for us then was like, okay, so in the history of Silicon Valley and sort of like the last kind of 20 years, every time you've had sort of an economically important piece of infrastructure that really controls a lot of sort of the GDP output of our economy and so forth, but that piece of infrastructure or that ecosystem is very difficult for software developers to integrate with. We've seen sort of a great API company emerge out of that problem, right? For payments, you have Stripe. For banking, you have Plaid. For telecommunication, you have Twilio. And I think we sort of saw this and we're like, well, IoT is very important. It controls the physical world. Software is very important because it sort of runs, to some extent, the physical world. How come these two things don't talk to each other, right? So that's why we started Seam. And so the kind of mission, sort of implicit idea behind, Seam is to build the API to the physical world. But I think like the more sort of comprehensible kind of like mission statement is, we sort of, it's been on our website for like 2 or 3 years, but, Seam builds digital and physical infrastructure. And the physical basically means hardware, by the way, to enable software developers and businesses to connect their applications with the physical devices around us. So we're not going to create like a full stack solution that does XYZ for a particular industry. We're also probably not going to get into the game of like building an actual thermostat or a smart lock, but we're going to sort of focus on like kind of doing everything in between, right? To sort of make sure that if you're creating an application and, you need to like unlock doors, you need to control the energy of a building, and you need to do that across thousands of locations and hundreds of different brands, that you don't have to do one-by-one integration, right? Like we're going to provide you a solution. And then similarly, if you're a manufacturer and you're like, wow, okay, I just created a device. Now I need to be compatible with the vast landscape of software applications that are out there that need to tap into my device. Like we're going to make sure that your device is like very quickly sort of integratable with all the, the apps and services that are out there. So in terms of like what the product looks like, sort of like kind of removing a lot of the grand ideas and the abstracts, we like to kind of explain our product as like 3 different pieces. And again, it's completely targeted as an API for software developers. The first thing we provide is kind of like an authorization flow. So if some of you are familiar with Plaid, when you connect your bank account with Venmo or, some of these financial apps, and it sort of asks you like, hey, which bank do you have? Log in with your bank credentials, and then eventually your bank account gets connected to an application. It's the same idea for sort of IoT. There are obviously some differences here and there when you start to get into like on-prem, systems that need to be bridged. But conceptually, the idea is we make it really easy to kind of connect your, device account with an application. The second thing, this is where we're going to focus a lot today, is sort of this idea of like providing a standardized API. So that, if I'm a software developer and I need to integrate with like 120 different brands of smart locks and access control system and so forth, you don't have to know about all the difference between them. Like really the idea is to provide a single API that kind of works across them. And so we'll discuss like, where this ideal can be done and where there are some limitations, and then how do we address those limitations. The last thing is we also provide a lot of UI components, and so a lot of that is also open source. But basically, sometimes it's not just enough to provide like an API to devices. You also have to provide like a little bit of UI for users to be able to like kind of see all their devices across like a portfolio of say buildings or so forth. So like we provide kind of like embeddable sort of web components that you can put directly in your application and help your users kind of like see what's going on with their devices. And it doesn't really matter what the application does, right? Like these things are sort of like industry agnostic. But the idea is really like we take care of all the data binding and sort of putting everything front and center for customers. I'll actually skip this slide, but I think I want to get now to the sort of like the inception of Seam and how we think about stuff. So the mission that you guys have is rather, is actually basically the same one that we have, right? We're just kind of stating it differently. You know, when you look at, you know, W3C Web of Thing, like it's like unlock commercial potential being held back by IoT fragmentation. And I completely agree. Like when you look at IoT devices today, like they're point solutions. They get, you know, manufactured by a company and they get programmed to do one thing, and then that's kind of where it stops. And the world we're effectively in is almost like the world of the iPhone before the App Store. It's like, yeah, you just bought a phone from Apple or from whoever, from Samsung, and it's got a couple of apps on it that are made by, you know, Apple, and it's nice. Like it actually does some useful stuff, but like it's not as powerful as it could be. It is grossly underleveraged. And the reason it's underleveraged is because like this entire ecosystem of people who write code cannot actually control and tap into the hardware. And I think that's effectively the same thing that's going on with IoT today. Like we have devices, we've completely commoditized the hardware layer. Like you can buy, you know, a device in any shape and color today for just about anything you can think of. We have Wi-Fi connected toothbrush now, right? So like all of that is here, but it's just still very hard to control it. And so for Seam, like we sort of say, well, you know, for us, it's about making it possible to control devices from applications. And so inherently, it's kind of the same idea as the way you guys sort of approach it. So when we started and when we started to think a lot about that stuff, you know, in philosophy, you know, there are different schools of philosophy, and the European and North American ones are a bit different. But like generally, you're supposed to kind of quote the greats, and you know, you don't really just like come up with ideas in a vacuum. It's preposterous, right? Like nobody does that. But you have to kind of like look at like, hey, what exactly has been done before? How do people think about stuff? And really, the coolest idea is kind of like the thing description, right? Like the idea that devices can be can sort of self-describe, you know, their affordances. And I think what's an even, you know, even cooler idea is the idea that you can take these, you know, thing description, you can take a device and basically say like, well, it has a set of actions, it has a set of events, it has a set of properties, right? And that sort of encapsulates everything you can do with this device. Like basically this device like can tell you what's going on. If it has a state, it can tell you what's happening to its own state, or maybe like the state of the world around itself. And you can also ask the device to perform certain actions. And I think it's like just a very beautiful summarization of like what IoT can do and how to abstract that. Now, the problem still with thing description is when you talk to our customers who need to integrate with a bunch of different brands, thing description doesn't actually solve the standardization problem, right? Like, or it doesn't solve rather the fragmentation problem, meaning that, yeah, it's great. Like if a device tells me exactly how, you know, to interact with it, you know, and like it's very useful because at least I don't have to necessarily like go contact the manufacturer to get like, again, like a 900-page PDF that's impossible to search to understand how to integrate this thing. But I'm still dealing with a bunch of different, you know, standards or things descriptions that I have to kind of like sort of code around. And so when you talk to people that are trying to do useful things with IoT devices, what they really want is, you know, ultimately what we provide as a company today, but it's kind of like the standardization layer of like, hey, there's a bunch of things description for each device, but ultimately what you really care about is this a door lock and can I unlock it, right? And I don't want to have to worry about, you know, it's this brand or that brand, or, you know, it's located in this country or that country. Like, I just want to unlock the door. Like, I just want to program an access code. I just want to change the temperature on this thermostat. So the question for us, like early on, was like, okay, well, we know about things description. What sort of things have been done along the way of like kind of providing more of sort of a uniform layer of standardization on top of all that? And I think the answer, like at least the one we found, you know, kind of like looking around and thinking through stuff, and ultimately the one that we sort of picked is the idea that you can basically have device capabilities, right? So the idea is like, yes, you have a bunch of individual devices. They have their thing description. They have a certain way by which you interact with them. But if my primary concern is to, you know, make two completely different devices from different brands kind of do the same thing, then like thing description, again, doesn't really help me that much if I now need to think about all the different permutations and different ways I need to reason about these devices. So capabilities are pretty helpful because all of a sudden you can grab you start with a single device and you can say, okay, what are the set of features of this device, and what are some of the features that are common to other devices, potentially in its device category or just kind of broadly speaking. And so for kind of like a door lock, you can have like, well, it has a lock and lock functionality. Some people call it closures, but it's the same idea. You got access code, you got battery, and then you got some sort of networking, Wi-Fi, Bluetooth, etc. And then what is also interesting, this is where kind of like, capabilities is almost like TD-like, is a capability can kind of like break itself down into properties, action, and events, right? It's kind of bringing back sort of together. And so I try to kind of go back and look at like, where these ideas kind of came from. But I think, Z-Wave, the Z-Wave Alliance, I think like sort of refers to it as kind of like command classes, which I think is inherently kind of the same idea. SmartThings did a lot of really good work on this. Pretty narrowly on sort of like the context of like the smart home, but still. And then obviously Mozilla, kind of web things, Ben Francis primarily when they really sort of, I think it was like the most, one of the most detailed sort of schema around capabilities. Now, I think our experience, at Seam is like, hey, these were all like super awesome efforts, but they all suffered from kind of like the same, like a limitation almost like of having seen the entire universe of devices. Like, it's not possible, for example, for Ben to like, when you read like the capability schema to really know about like, oh, like here are the 100 plus different smart locks that are out there. Actually 600 plus is how many we've counted so far. And this is like all the different ways things can work. And so when you read kind of the capability schema, very quickly you start to see holes in sort of the precision of the logic, or you can identify areas where like, well, this isn't really going to work for like this particular brand or this particular brand, right? So I think the initial premise was really good. I think it just kind of lacked, a lot of sort of hands-on experience, right? And that takes, you cannot fault them for this. This takes time. You need an entire hardware lab where you play with devices, where you actually purchase them, install them, control them. And then you also need customers that tell you like things that they want to do, and you start to run into edge cases that they're running into, right? And so I think for us, it was just like, okay, this is a really good starting point, but like, we need to sort of improve upon it. But the idea of capabilities is like really awesome because it sort of lets you do like things in like a standardized manner from here on out, right? Like I have this like little code sample here, but you can unlock a door, and it doesn't really matter if it's like a Salto device, a Yale device, a Schlage device. It just unlocks. Like it will work like this every single time. Now we do a lot of things behind the scene to sort of asynchronously sort of take care and making sure that these things eventually do happen. Like I don't think you can just kind of like connect two things with a piece of code. You actually need quite a bit of infrastructure to make this work. But the idea of capability is pretty strong. Similarly, creating access codes, on devices. And so that's the approach that we take at Seam. It's like we are trying to, every single time try to grab like an entire sort of device landscape or device category and sort of say, okay, what are the capabilities within these devices, and then how do we need to sort of craft, our API and our SDKs to kind of make this work. Now, the truth is, some brands are just not going to fully like. You're not going to be able to like completely standardize things, right? Like you can imagine this like create access code function that we have where you can actually specify the code that you want. You could say like, hey, I want the code to be like 1234 or 048 in this example. And maybe in like 90% of the use cases or the brands that are out there, that's going to work. But there's also going to be brands, and some of them are quite large, where you just can't do that because the brand doesn't, allow a leading zero. Right. And it's like, why is that? Well, I don't know, like, but they just don't allow it. I actually have my suspicion that it basically comes down to like the way they're storing these digits. They're storing them as like integers as opposed to storing them as string. And so like, there's no such thing as an integer that is starting with zero, right? Like it's hard to, you can, but it's hard to represent in terms of like the exact length and all that stuff. So, but the reality is like, you cannot completely sort of blanket over the differences that exist, in the world of IoT, right? Like there are just going to be things that kind of, rear their ugly heads, and you just have to kind of deal with it. And I don't think it's also realistic, by the way, to sort of say, well, we're just not going to support certain devices. because that's not the way the physical world works. There are people who've already installed millions of those devices, and so you need to find a way to support them. And I also don't think you can sort of force manufacturers into complying with, well, we want you to basically make sure that I can have a leading 0 on an access code. Manufacturers have many, many things to worry about. And I think that this probably would not be very high up on the list. And on top of that, like, even if they were interested in doing it, there are still very hard limitations to doing that. Like, sometimes the hardware doesn't support, doing something very specific, or it requires an OTA, right? An over-the-air update for the devices. So it's very, very difficult to kind of like really hope for like an idealistic world of where everybody's sort of like, kumbaya, and everything starts to work like exactly the same across brand. Like, that's just not going to happen. So the reality is, like, capabilities are not perfect, but you can still document the rules, especially across different brands and different models and different firmware version, to help sort of guide the logic around sort of, say, setting access codes, right? So for SIM, for example, we sort of say, hey, like, you have a device, one of its capabilities, is access codes. And then you can basically say, hey, look, like, this is the set of code length that this device takes. This is the maximum number of code that you can have. You can't start with a 0, right? Like, you can have constraints. You can even have constraints on the name of the access code, right? So when you do stuff like this, then there's some interesting things that emerge out of this. So like, this kind of sucks, like, to some extent, because you're kind of saying like, well, now you have a leaky abstraction. Like, now as a software developer, I'm not fully back at square one, but kinda, right? Like, I kind of need now to think about like the differences between, like, say an Igloo door lock versus, a Schlage one or whatever. But it actually turns out, like, if you're very, very user story driven, you can still solve for these things to bring it back into sort of innocence land of like, I don't have to worry about these differences. So this is like a pseudo real example, but like, say you have, it's very, very common in the world of Airbnb that the reservation softwares, they want to program an access code for a guest, an Airbnb guest that needs to enter a home. And they want the code on the door to be the last 4 digits of the Airbnb guest telephone number. And again, like, we're kind of like, well, that might not always be possible, right? Like, what if there's a 0 like in a telephone number, or what if there's, some weird like code length requirements or whatnot, or what if there's already an access code that matches the exact last 4 digits? And so the way to kind of solve this is to sort of say like, well, on top of the capabilities, now we can sort of offer like kind of like assist functions where, you can say, well, okay, so I want to create an access code on this device. I'm going to give it this name, like an Airbnb reservation. And then I want to be as close as possible to the telephone number of the guest, and maybe preferably using the last 4 digits. But if that's not possible, use any other sequence of 4 digits that's in their phone number, because that will still be an easily memorable code that the guest can use. And so when you send that to SIM, or conceptually to like anyone, well, we can basically say, okay, like, the last 4 digits is 0550. Well, we got a problem because we can't start for 0. And so what we say is like, well, if you drop kind of like the internationalization number and just like look at the area code and stuff, it's like, okay, 5158. Yeah, we can do that. We can grab that. And that will effectively satisfy the user requirement, the user story requirement, which is the code that gets set on the door for this Airbnb guest. It has to be easy for that Airbnb guest to remember that code. Well, it turns out the code is the first 4 digits of their telephone number, right? So this is kind of like how you start to get around some of these sort of fragmentation of even just simple things like what is the format of an access code. So I hope this kind of makes sense, like how we're kind of coming at this, like, from a slightly kind of different point of view. And I think like generally like our strategy is to say, okay, when and where there are economically important devices that may or may not exist inside of a smart home, right? It could be out in the world, it could be inside of a building. We're going to try to figure out a way to create that standardization layer so that third-party software applications can control these devices and sort of kind of like unleash their full potential. And so as a company, like, again, being very sort of user and customer driven, we actually chose to start with kind of access control and smart locks and things like that. We didn't really try to take like a sort of boil the ocean approach of like try to, do everything that's inside of a house or everything inside of a building. It was very much like, show me where are the problems. Let's figure out a solution people are, build something people want, right? And it turned out that the idea of programmatic access, like being able to programmatically grant access to a unit of space to an individual is something that people want, right? So that's kind of why we started there. But even though like the majority of the integrations and the things we sort of support today is access control, like if you actually look at like some of the things that we're starting to do or talk about publicly, it's like we're starting to expand to like other stuff. Like we have a couple of thermostat integrations now. We have a couple of sensors. I think you're going to see us move probably next into kind of like sub-meters, things that you see in buildings for like individual like energy usage, because we are seeing customers asking for these. And then kind of the big one for us that I still don't entirely know exactly when we release it, but like the idea of like sensors and especially cameras. Like there are a lot of applications that are trying to utilize vision, sort of computer vision to do things around safety or monitoring or whatever. And they run into the fragmentation problem of like, hey, there are too many different standards or too many different brands and it's too complicated. And so being able to just kind of like have an API, you connect to a camera system, and all of a sudden we give you a live stream. Perhaps we even enrich it, right, with like sort of like object segmentations and things like that on top of it, and construct that as an API product to let other people build stuff on top. I think that's a really cool idea, right? So that's kind of how we sort of approach that. By the way, this camera stuff is really, really hard. I think video infrastructure is non-trivial. We primarily write stuff in TypeScript, and for that, obviously, we're starting to do a lot of Rust because you just have like latency requirements and things like that. So it's pretty tricky, but I think it is again like an economically important device category that you have to go after. So on that note, kind of like the last slide, we are hiring. It's a little bit of a global company. I think many people are here in San Francisco, but we have people throughout the United States. We have a couple of folks in Europe. Same for Asia. We tend to sort of say like, we're looking for sharp minds with kind souls. Or we could have sort of said curious and sharp minds. I think when people are, if you look at the people on our team, like they tend to be very into this idea of like, I can write code and, I can unlock a door in Japan from, my desk in San Francisco. Like that's such a cool, it's such a cool idea. And so I think like the people here tend to be like pretty motivated by sort of like what this can potentially enable. And so I think that's generally kind of what we look for. We don't generally segment between like back end or front end or whatever. We kind of want people that can sort of go anywhere on the stack and do things. Because generally you kind of need to have like a sort of a broad understanding of like how everything kind of works. So it makes it harder to find people, to be very honest with you guys, but it is important for us. And then we're also looking for like technical sales and product managers, because like selling, well, first of all, you have to build a real business, right? So, why do we need sales? Like, well, we have customers that come in, and sales is fundamentally about helping people. It's not about making money. It's about helping people. The natural consequence of helping people is that you get paid, right? At least in this particular context. But finding people that really understand IoT, that understand APIs, that understand how software developers work, like not a whole lot of people like that. And so we actually spend a lot of time looking for, folks that can do technical sales. And then same for product managers. We interview a lot of product managers from, really, really awesome companies. And very often we're like, great, like you shipped, an app to 1 billion people for photo sharing. And you seem super smart and super good, but when it comes to the realm of IoT devices, this doesn't quite cut it for us. Like it's not sharp enough, right? So I think generally like these are sort of like the 3 or 4 roles we can look for. If you have, if you really want to work at Seam, you find, the problem interesting, you sort of kind of believe in the mission, like, but the thing that how to do isn't necessarily listed on here. Like, you always reach out. I think again, I think the fundamental heuristic is sharp minds with kind souls. So I'll leave it here. I think we'll